I didn't know it was going to do that. So I have at the very top, just so you know, that's blood splatter. And I'm going to show you how to do a blood splatter analysis in here using trig functions. It's really fun. We won't be doing that this week. We'll be doing that next week. But it's a blood splatter analysis because it uses trig functions. But one of the sites I came across, it's obviously it's not like all forensic scientists and cops are well versed in pre-calculus. So it's not like they take out, here's my unit circle that I tattooed on my arm and I'm going to figure out how to do, it's not like they do that. They actually have little pieces of software that shows them how to get these, get the blood splatter analysis. What they're looking for is where the location of the crime is from a blood splatter analysis. So that's a really fun thing that we're going to do in class. We're going to experiment and actually do it and use trig to back calculate where the origin of the crime came from. We won't be using blood unless I get more questions in here. No, I'm just kidding. We'll be using ketchup, just so you know. Okay, so this is off the next set of homework that's due for the following week, February 9th. It's already posted. A lot of it is quick. So I think more than anything, it's going to be questions that you have, how I came up with these things. So the first question is what this part is about back calculating angles. And that little inverse sign means back calculate the angle that gave you square root of 3. So the goal is when you're asked a question like this, you want the angle that yields square root of 3 when you tan it. It's just like the idea of back calculating an angle when you are looking at a blood splatter. And blood splatter, what you're left with is you're left with the scene of this crime. You have the blood splatter laying there, and you would like to know what angle did it come from. So you want the angle. You don't want the tangent of the angle. You want the actual angle, for example. So it's a back calculation. And that little inverse symbol, that -1 symbol, means back calculate. So what our goal is we want the angle that gives us square root of 3 when we tan it. So on your unit circles, I've already been asking you these questions, right? Give me the angle that gave you this y value, or give me the angle that gave you this x value. So I've already been asking you this. Okay? It just looks scary when you see the minus sign symbol. The symbols are just denotations for something that you're looking for that's probably very simple, and it is very simple. So once you understand what the problem is, steps, you first set tan of angle to whatever's inside that argument, because that's what you're looking for. That's what you want. So just rephrase it so it's simple. So that the tangent of the angle you're looking for is square root of 3. So you repose the problem. What do you want to find? What's it you want to find? The angle. So the second step, how are you, Jonathan? You want to come do blood splatter analysis?
Is that today?
It's going to be next week.
Oh, yeah, definitely.
You really seriously want to?
The blood splatter analysis? Of course.
All right, we'll invite you.
That was me.
Okay.
Today?
Yeah, we're meeting at 2:30.
Oh, 2:30. Oh. Okay. Thanks, Dr. Steve.
See you then. Transform the tangent to sines and cosines. That's always our MO, right? We have to change everything in sines and cosines because those are the dollar bills. Tangent is sine over cosine, so that's what it means. So sine of the angle divided by cosine of the angle is equal to square root of 3. And now you go to your unit circle, which everybody will have because it's number 1. It's the number 1 question, so you already have it on your test. So go and find that angle on the unit circle. There's my unit circle, drawn a lot neater than when I did it in class because it's computer generated. And I just go look at where sine, the y value, is going to have a square root of 3 in it. Can you see any y value? Because sine is the numerator, right? So where is anything have to do with square root of 3 that's on the sine and the y value? Pi over 3. And I knew you were going to say that, so I highlight it. And see that's sine of pi over 3 square root of 3 over 2. But I have to deal with the x too, right? Because sine over cosine. So I'm just going to guess, I'm going to make a lucky guess that it has something to do with that angle over there because that's the only one that seems to have a square root of 3 in it. There's another one too. I'll come to that in a second. And I'm going to see if it works. I'm going to put the sine over the cosine of that angle. Sine is square root of 3 over 2. Cosine is 1/2. What do you do when you have a fraction over a fraction? You've been practicing, right? We thought about this. We thought about this at home a little bit. You can't just mumble it once in a while. Sometimes you have to shout it. So you have to go and invert the denominator, invert the denominator, multiply, and then people will really think you're nuts, and they'll move aside. And there it goes out. We kill those two things out. I think when someone's trying to approach and sit by you, that's when you should shout it. It'll work. Apparently, somebody told me there's a website that says, that's called Hobo or Physics Professor. You have to guess which one is which. And one of the faculty members said he got 80% of them correct. I think that's what the site is called. Maybe I'll send it out to you and you guys can take the test. Okay, there's, by the way, I don't have to do the math again. If you notice, there's another place that has where the signs are the same. What happens when the signs are the same and you put them over each other? They'll cancel out, right? So this is another site on the unit circle that the tangent of the angle is going to be square root of 3 over 2. I don't have to do the math again. It's going to be the same math as here, except the minus signs will cancel out, right? Hey, he's got Rangers today. No New Jersey teams? What about the Devils and
Not a Devils fan.
So it works. Those two angles work. And that's the answer I pop in. That's good? It's actually pretty easy. I just slowed it down so you could see the steps. Clear? Questions come later.
So how can we use 5 pi over 3?
That's a good question. So let's go back and look at why. 5 pi over 3 is right over, I'm not supposed to walk over there, right? I'm right over here. The signs will be off. You'll get minus square root of 3.
Oh, so you want to positive.
Right, it said positive, so that's why I got those two. But you're right, just to be careful, you should just check and make sure, but you can eyeball check, I think, that the sign will be off. So on the quiz, by the way, you can actually do this on the calculator. All you have to do is tan inverse of whatever. It might give you only one. I think the better your calculator is, the more new it is. Like I think the 84 plus should give you both angles. I'm not sure. You should try it. But you have a tan inverse or you have an arctan on your calculator. They mean the same things. Pull out your calculator and see what you have, and I will. It either will have tan with the minus sign symbol, a minus 1 symbol at the top, or it will have a tan. They're the same thing. And you can put in the angle, have it in radian modes, and then click, and it will give you the. But the problem with that is it'll give it to you either in decimal form. The 89s have just been banned from our department. So, but I think the 89s will actually give you pi divided by 3.
Maybe what?
They've been banned.
In math class?
Huh?
In every math class?
Yeah.
Oh.
If you're not taking another math class again, I think they're discontinuing the 89. I heard that they're not making them anymore. I just bought one. I think it's cool, but.
You mean the like tan like to the -1 power?
Let me take a couple looks at your calculator. What do you have? 86.
84. Like in the blue.
Yeah, that's right. The blue one. If you have an 86 or 86 plus, it's on the blue. So you have to use your shift key. So it's right over here. The tan inverse. Right. So that's the thing. It gives you 2 decimals. The 89, I think, gives it to you as the pi symbol divided by. So it'll actually give you the angle. So it's only giving you one of the angles and it's giving you a decimal. But you can use it to check your work.
I got pictures that I've calculated.
Right, so the decimal answer. What you can do, how you can check is you can do pi divided by 3 on your calculator also. I think you have a pi button, don't you? If You have a pi button, so do pi divided by 3 and see if it comes out to 1.404. Check it out. That's how you can check your work. So you're definitely encouraged to check your work with the calc. You should be. You paid enough for it. You should use it. Okay, are there any questions of how to? It's nothing new. That's why I made you learn the circle right away, because I knew that you could answer so many questions off of it.
But because I didn't do 4 pi divided by 3, I got 4.180.
So it won't give you the second angle. That's another limitation of the calculator. Unless you have the 89, which is banned.
So if I have 89, can you make it plus?
You can use that. Just don't ask, don't tell policy. Okay, so on this problem, you're supposed to actually get a decimal answer. They say round your answer to 2 places. The first step is you have cosine inverse cosine of 6. So set y equal to cosine inverse cosine of 6. That's the first step. These are easy, I promise. Step 2 is to cosine both sides. So take the cosine of y and cosine of the other side. These two things are what we call inverses of each other, cosine and cosine inverse. So they cancel each other out, they go away. And you're left with cosine y is equal to cosine 6. That means that that y inside must equal 6. Kind of nice. Simple. And the reason they're asking you is they just want you to recognize that they're inverses of each other and they cancel each other out. Right? In biology we call it back calculation. So sometimes you have, I'm doing this right now. I work with these doctors on placentas. Placentas, only women will get the placenta. It's a beautiful organ. It's a metabolic exchange for the fetus in utero. And at term, they have the placenta and they have the baby. Can I tell you from looking at that placenta at term what happened inside during the pregnancy? That's a back calculation. I have information at the end. I want to know what happened before that. So in all of mathematics, we sometimes want to know what happens in the future, but sometimes we have a piece of data in the future and we want to back calculate and know where it came from or what happened. The problem of blood splatter I just gave you is a perfect example of that. Already happened. I'm not trying to predict the crime. Already happened. I'm trying to back calculate and figure out what happened when I wasn't there. And anything that we know about the universe, it's a back calculation, right? How can, whenever we use math, we don't, it already happened. We're not trying to predict something. We're trying to back calculate and see what happened. All right, this one's a no calculator. No calculator means that it has to come from the unit circle. That's the only way you can do things without the calculator. Step 1 is as before. You let y equal to the cosine inverse sine of pi over 4. Step 2, cosine both sides. Why do I cosine both sides? Because I'm trying to undo this cosine inverse. The opposite of a cosine inverse is a cosine. So I cosine both sides. Then I simplify that mess. Well, cosine of cosine inverse is what? What does it do? What does a cosine and cosine inverse do to each other? They cancel each other out, so it's gone. So they cancel each other out, and I'm left with cosine y is equal to sine pi over 4. And I know what sine of pi over 4 is because on page 1 of my test or quiz is that unit circle. So I can just go to pi over 4 and look, and it says the y value is square root of 2 over 2. So this comes from the unit circle, just pulling off.
Why does that cancel?
Because cosine and cosine inverse are inverses, right? They're back calculations of each other, right? So now I have a different problem to look at. I have, what angle does cosine equal square root of 2 over 2? Some of you had a quiz that had exactly that question on it. How do I figure that out? Remember, I asked you in order. I gave you the unit circle, and I asked you which angle does cosine equal blah, blah, blah. So you go over to the x value, and you look where it's equal to square root of 2 over 2, and I get 2 answers. You see that? You just did that on the quiz, and most of you did it well on the quiz. So it's just a different way of asking that same question, which in Math 103, which is the math for students who are not going into science, that's what they think math teachers do. They just ask questions and make it really complicated. It's the same question I asked you on the first quiz. There it is. So I get y is equal to pi over 4, and y is equal to 7 pi over 4. That must be really annoying when you're taking notes that I have an entire computer graphic unit circle drawn up. So just put unit circle. So that's the answer. Question?
Oh, never mind.
Got it?